If you only look at the old screenshots, Rust looks like the winner, Go looks messy, and .NET barely belongs in the conversation. But once the benchmark was rebuilt from the May 26 official lanes, the clean story stopped being clean. So I am treating v2 like a claim on trial. The question is not whether Rust is fast. It is whether the old verdict survives once we add the fair Go lane, the official .NET AOT lane, tail latency, dropped iterations, and recovery. Before any leaderboard, look at the project. The implementation lanes, benchmark scripts, and artifact folders are all visible because a benchmark you cannot inspect is just marketing with numbers attached. The runtime topology is the fairness frame. ART drives closed-loop throughput. K6 drives open-loop tail and recovery. All 4 official lanes hit the same Postgres target, and the final claims come from 1v3. Evidence surface. The full test matrix is where this stops being a one-number video. Read throughput, write throughput, P99, P99.9, dropped iterations, and recovery all tell different parts of the same system behavior. The implementation code matters too. Rust, Gochi, and .NET AOT are not literally the same runtime, but the endpoint contract is intentionally boring. Validate the id, read from Postgres, return the user, and let the benchmark expose the runtime behavior. Only after that do we get to the benchmark contract. Same database target, same pool policy, same warm-up rules, same timed phases, and one official publish lane per stack that can be defended on screen. The terminal replay is deliberately plain. Each lane runs, each lane writes artifacts, and the aggregate script builds the v3 result set. That boring trail is what makes the later chart drama worth trusting. The exclusion rule is strict. .NET JIT is not missing because it lost. It is out because this host never produced a valid merged v3 artifact for it. In this video, incomplete evidence does not get a leaderboard slot. The artifact scene is the source of truth. We are looking at the canonical results file and the generated summary, so every winner in the video has a path back to the repo. Now the first headline lands, Rust Axum wins read throughput at concurrency 200 with a little over 22,000 requests per second. If your bottleneck is raw read capacity, Rust gets that point cleanly, but the leaderboard flips the moment the metric changes. Switch from read throughput to P99 and Gochi moves to first. Switch again to P99.9 and .NET AOT takes the deep tail win. Dropped iterations make the story sharper. Fiber has a real recovery win later, but in the open loop tail run it also drops the most iterations. That is why fast and stable under pressure cannot be treated as the same word. Recovery gives Fiber its best argument. When the pool gets stressed and the service has to snap back, Fiber posts the fastest recovery P99, with .NET AOT close behind and Rust still respectable. Scaling explains why the standard library Golang matters. Fiber starts high and falls hard by concurrency 500, while Rust stays high, and Gochi holds a much flatter shape than the faster-looking Fiber headline suggests. The trade-off plot is the whole video in one picture. Rust is high on capacity but weak on P99 tail. Gochi is far left on tail safety. .NET AOT lands in the balanced middle with the best deep tail, and Fiber becomes a specialized recovery story. The fairness meter is not a performance result. It is a reminder that Fiber is a fast TP lane, while Chi, Axum, and Kestrel are closer baseline classes. That caveat does not erase Fiber's wins, but it changes how you interpret them. So the final answer is not a trophy. Pick Rust for raw read capacity, Gochi for P99 behavior, .NET AOT for P99.9, and the official C# lane, and Fiber for recovery if the framework class trade-off is acceptable. What v3 proves is narrower than a final all categories benchmark. It proves throughput, tails, recovery, and fairness policy. It does not yet prove CPU efficiency or cold versus warm startup because those aggregate artifacts are still missing. That is the channel promise here, not just bigger bars, but the harness, the code, the artifacts, and the uncomfortable caveats. Subscribe if you want benchmark videos where the evidence is visible enough to argue with.